Okay, so this is going to be my most difficult differentiation question so far, all right? We will be differentiating this giant expression. And I think some of you guys recognize what this is, right? This is the result that we got from the integral of square root of tangent x. So you know, after all the work, we should end up with just a square root of tangent x, right? So this is how we are going to check our answer. And by the way, you can totally give this to your maybe calc 1 friend or so to test their differentiation skills. All right, first of all, you notice that we do have two terms and they look similar, right? They both have a lot of things in common. And the only thing different is this was negative, this is positive, but this is a hyperbolic version of the inverse tangent. This is the regular one, and here we have a plus, and this is a minus. Hopefully, a lot of things will cancel out nicely, all right? Anyway, let's get to work. So we are going to start off with this term. This is the first constant multiple, negative 1 over square root of 2. So let's just write it down, negative 1 over square root of 2. And then we'll differentiate this, right? So first, you have to remember the derivative of the inverse hyperbolic tangent is 1 over 1 minus something right there inside, square. So we will multiply 1 over 1 minus the inside is this. So I will open a parentheses, I'll put this inside, square root of tangent x plus square root of cotangent x over square root of 2, and then we square that. And what's next? Well, we know the inside here, we have to differentiate that, right, by the chain rule. So let's go ahead and do that. First, notice that we have this and that over square root of 2. So that's a constant multiple. Let me first write that down. We have this 1 over square root of 2. And then we'll open the parentheses. So we can focus on differentiating square root of tangent x, and then we add it with the derivative of square root of cotangent x. First, the derivative of square root of something, we know it's 1 over 2 square root of the inside. And now the inside is just tangent x, so we can just write that down. And you are going to ask yourself, what's the derivative of tangent x? Because we have to do the chain rule again, right? The derivative of tangent x is secant square x. We multiply by secant square x. And let me just put it on the top to save some space. This right here is secant square x, okay? And we do the same thing for the next one. We will be adding with, once again, the 1 over square root of 2 is in the front already. So we're just focusing on to differentiate square root of cotangent x. All right, so we have 1 over, let me just leave blank for now, 1 over 2 square root of the inside. This time is cotangent x. And what's the derivative of cotangent x? You have to remember this really well. It is negative cosecant square x, right? Negative cosecant square x, like that, all right? Okay, so this is the first part. And now, moving on to the next part. Okay, we add 1 over square root of 2, and then we differentiate this guy, which is going to be 1 over 1 plus the inside square. This is square root of tangent x. And this time, this is a minus in between, minus square root of cotangent x over square root of 2, and then we square that. And just like the first part, we have to differentiate the inside by the chain rule. And I will also put down the 1 over square root of 2 first. So we have the 1 over square root of 2, and then we differentiate the derivative of this and the derivative of that. Well, it's pretty much this and that, but with a minus in between, right? So the derivative of this is just that, which is secant square x over 2 square root of tangent x. And then in between here, it's a minus, and then over, we have this. So let me just write it down. 2 square root of cotangent x on the bottom, and on the top is negative cosecant square x, right? And this is it. This is what we have. A lot of things are in common, so this is really pretty, right? And now, let's fix something. Let's fix a complex fraction, namely this right here and this right here. Hopefully, a lot of things will work out nicely. Okay, so I will do this in blue and red. First of all, this is just the 1. I'll put this down in blue, and then minus. Okay, we have this square. On the top, we have two things adding, a plus b and a square, right? Well, we know this is going to be a squared plus 2ab plus b squared. A is square root of tangent x. You take that square, you'll just end up with a regular tangent x, right? And then you add it with 2 times this and that. But we know tangent x times cotangent x is 1. Likewise, square root of tangent x times square root of cotangent x is still 1. So you just add 2 times 1 pretty much. And then you add it with this square, which is regular cotangent x. And then over, you have square root of 2 square, which is just a 2. And technically, I still have to put parentheses because we have the 1 in front, right? We have 1 minus all that. Okay, now, remember, this is just the denominator. And we have 1 over that. It's still a complex fraction. To simplify this, let me just multiply the bottom by 2, and likewise, let's multiply the top by 2, right? So you will see, when I do 2 times that is 2, and 2 and 2, they cancel. I will have to distribute the negative right here, so we end up with negative tangent x and then negative 2, right? And then negative times that is negative cotangent x, right? And as you can see, 2 minus 2 is 0, so they cancel out. And right here, I have negative tangent x minus cotangent x. I can factor out negative if you would like. Let's do that. So we have negative, and then inside now it becomes tangent x plus cotangent x. And the beauty here is that we have this negative on the bottom, and then this is a negative 1, right? And then they're multiplying, of course, we can cancel them out. Negative becomes positive, everybody happy. So this part wise, we will just have 2 over tangent x plus cotangent x. And now this part is pretty much the same thing, right? So let me just repeat that. On the bottom here, we have 1 plus, we have to square this. So this time is just, once again, we have the tangent x, but this was a minus, so we have to minus 2 times this and that, which is just minus 2. And then we add it with this square, which is cotangent x. On the bottom, we have a 2, right? And similar to that, I will just multiply the bottom by 2 and the top by 2. On the bottom, you have 2 times this, which is 2. This and that cancel. Let me just write this down. Plus tangent x minus 2 plus cotangent x. And once again, this and that cancel, right? So you see, this is actually just the same as that. 2 over tangent x plus cotangent x, right? And you notice already, 1 over square root of 2, 1 over square root of 2. And the second part is 2 over this, 2 over that, same thing, right? And we also have 1 over square root of 2, 1 over square root of 2. So we see all those things are in common, so we can actually factor them out first. So let's do that right here, okay? So let me just put things down in a nice order. First of all, let's factor out this 1 over square root of 2. So let me just put that down here. Next, this, right? That's the one we have in common. So let me just write that down. So we factor this out, which is 2 over tangent x plus cotangent x, right? This and that, same thing, it's out. One more, we have the square root of 2 on the bottom, right? 1 over square root of 2, like this. So this is out here, this is also out there. Okay, now let's take a look at what are the things that we have left inside of the big parentheses. So we pretty much have this, that going there, right? Let me just not be lazy and write them down for you guys. So I have this, I know this and that cancel, but let me just write it down. Well, you'll see. This right here, secant square x over 2 square root of tangent x. And then this is actually a minus, right? It's a minus, positive minus, right? Minus cosecant square x over that 2 square root of cotangent x. And then we have this and that, put it down. This right here is the positive secant square x over 2 square root of tangent x. And notice this is minus times minus becomes positive cosecant square x over that, which is 2 square root of cotangent x, right? Aha! This and that cancel out, right? So good right here. And I will also fix a few things. On the top here, we have a 2. And then square root of 2 times square root of 2 is also a 2. So I can cancel this 2 out with this 2 square root of 2's. So all in all, what do we have? Let's take a look. First, right here, we have 1 over tangent x plus cotangent x, right? But let me just tell you, I'm going to leave that for now. Times, what do we have left inside? Well, we have the 2 square root of tangent x on the bottom. So let's put that down. 2 square root of tangent x like that. And on the top we have secant square x plus secant square x. So we have two of them, so we can just add them up. So be sure this is the 1 plus 1. We have the 2, right? Secant square x, right? Hopefully you guys don't get intimidated because I put down 1 plus 1 is equal to 2 again. Anyway, you see right away this and that can be cancelled. That's nice, right? Okay, now earlier I was supposed to put this down here, but if I did tangent x plus cotangent x, you wouldn't see too much. And the reason that I didn't do that is because right here I am going to write tangent x as sine x over cosine x. I can totally do that, right? And then I'll be adding this with cotangent x is the same as cosine x over sine x. And now what? Complex fraction, we do it the usual way. Multiply the top and bottom by sine x times cosine x. Let me just put it down here. Sine x, cosine x, top and bottom, right? And as you can see, when you do sine x, cosine x times that, the cosine x cancel out, and then you have what? You have sine x times sine x, which is sine square x. And then next, when you do this times that, the sine x cancel out, you have cosine x times cosine x, so you have plus cosine square x. And this is exciting because sine square x plus cosine square x is just what? 1, right? So this is right here. On the bottom is just a regular 1, okay? And on the top, what do you have? Sine x times cosine x times 1, okay? All right, now to finish things up, let's do it this way. First, I have the sine x times cosine x. Let me just keep it in blue. Why not? Sine x times cosine x. And then for this right here, we have a secant square x. I would like to write that as 1 over cosine square x. And then over, on the bottom, I have the square root of tangent x. And now what? You see, this is cosine x, and then we have 2 of them on the bottom. So this and that cancel out, right? And now we just have 1 of them on the bottom. So we still have just cosine to the first power x. On the top, we have sine x times cosine, sine x times 1 over cosine x. And that's what? This right here on the top is just a regular tangent x. Over on the bottom, we have this square root of tangent x. And this is what? Of course, do it whichever way that you want. But you know at the end, the deal is that this will simplify to square root of tangent x. And we are done. This right here is the answer. And that's the hardest derivative question, in my opinion. Well, until today, I think. And anyway, of course, this is so pretty as well. And this is why I owed you guys, because I make a small mistake in my first upload for the integral of square root of tangent x. But here we have it. This is the check by differentiation. Hopefully you guys like this. And if you do, please hit that like button and share the video. That would be so wonderful. Thank you.